we are open for questions. What kinds of questions do you guys have? If it's anything off of the review that you were working on yesterday, I'm willing to do something that's like those problems, but I won't do those exact problems since you have each other's videos to look at for that, okay? Anything off the homeworks, anything off of either of the reviews, anything that you want to see or know how to do. Yes, sir?
Rationalizing the numerator.
Rationalizing the numerator, yes. Let me get a couple examples written down off of here. All right, so I'm going to grab, I think, 2 of these, and we'll go through them. So 1 minus the square root of 3 plus x over x plus 2. And then I'm also going to grab the very last one, part C. Over x minus 4. Okay, so our task is to rationalize the numerator. Okay, so when we rationalize the numerator, we don't want any radicals at all in the numerator. If there are 2 terms with a plus or a minus in between them, then we will multiply by the conjugate. So this would be considered a term, and this whole thing would be considered a term. And I've got subtraction in between them. I got this question quite a bit yesterday from several different people. It's a great question. When I say we're multiplying by the conjugate, we know we need our 2 terms and we're going to change the sign. That would not include the plus sign that's under the radical. You do not change that sign. Only the sign that's in between your 2 terms there. So only the subtraction in between the 1 and the radical. Does that make sense? So I'm going to multiply top and bottom here by 1 plus the square root of 3 plus x when I multiply conjugates together, it is exactly the same process as when I multiply the 2 pieces for a difference of squares together. When I multiply a difference of squares, we distribute. So I would get x squared and then minus 5x. Because they are identical except for the sign in between the terms, these pieces right here, these middle values, will always cancel out. That's why we're multiplying by the conjugate there. We want these middle terms to cancel out. So what I end up with is my first term squared and then it will always be minus my second term squared. So looking up here and trying to translate that idea to what's going on with our radicals. Let me kind of scoot that down a little bit. My first term is a 1. What do I get if I square 1? 1. I don't need to multiply the 1 to the radical or the negative radical to the 1 because I know those pieces are going to cancel out. It is going to be minus after that. And what do I get when I square a square root? Yeah, it's going to cancel out. So I'm just going to have the part underneath the radical left. Keep in mind, though, that underneath that radical, there are 2 different things happening there. I'm going to subtract all of that term. So I'm subtracting both pieces. We're not just subtracting the 3, we're also going to subtract the x. And then that's going to be over my denominator. For this part, I would not distribute these pieces. I don't distribute those for a couple of reasons. The biggest reason is it's more work than I need to do. The second biggest reason is if I distribute, it's going to make it harder for me to see if anything's going to cancel out and reduce in my fraction. If I leave it in factored form, then I can see if things are going to cancel much, much easier than if I distribute. I still need to simplify my numerator a little bit here. I'm going to distribute the subtraction to both pieces. So I would have 1 minus 3, which would give me negative 2, and then minus x. All over x plus 2 and 1 plus the square root of 3 plus x. Can that numerator factor at all? I can take a negative 1 out. If I take a negative 1 out of my numerator, what does it change it to? X plus 2. Do you guys see why I left that denominator in its factored form? What do you notice? I can cancel out those x plus 2's. And so fully rationalized numerator, I have a negative 1 in my numerator, and in my denominator I have 1 plus the square root of 3 plus x. Let's go look at this other one. Same exact pattern here. I have one term right here, and I have another term right here. So when I multiply by the conjugate, I'm going to have x square root of x plus 8, top and bottom. So again, my denominator, I'm going to leave this in an unfactored form. Or sorry, undistributed form. I'm going to leave it in factored form. I said that totally backwards. So my denominator is x minus 4 and x square root of x plus 8. Up in my numerator, I'm going to square the first term. I'm going to square the second term, and it's going to be subtraction in between. What happens when I square the first term? So I have x square root of x times another x square root of x. What would that give me? If you do x times x, yeah, we're going to end up with x to the third power. X times x would give me x squared. And then I have the square root of x times the square root of x, which would be just x. So altogether, I get x to the third when I square that first term. So I have x to the third minus, and then I'm going to square that second term, which is an 8. What is 8 squared? 64. What do we call what just happened up on our numerator? Difference of cubes. How do we factor a difference of cubes?
A plus b, a squared minus a times b minus plus b squared.
Yes. So I need to know what my a and my b are. So I'm going to cube root both of these. What's the cubed root of x cubed? X. What's the cubed root of 64? 4. And then what's the acronym that I use to help me with my signs? SOAP. What's that stand for again?
Same opposite, always positive.
Same, opposite, always positive. So my numerator, when I factor it, is going to be, I know it has the x and the 4. Is it going to be a minus or a plus in there?
Is that supposed to be an 8?
Is what supposed to be an 8?
The 4?
Nope. The square root of 64 is 8, but the cubed root is 4.
I thought it was 2.
The cubed root of 8 is 2.
Well, wait. Oh, you.
Because 4 times 4 would give me 16 times another 4.
Yeah, I was.
Gives me 64.
I was doing like square root of 64 was 8 and square root or to the third.
And then cubed root of that. Yeah.
Sorry.
That's okay. What do I want in between the x and the 4? Minus. Because?
Same.
Same sign. And this was x cubed minus 64. And then over here, I'm going to have x squared. We multiply the a and the b together to get 4x. And then I square the last term, so I would get 16. Tell me what my signs should be there.
Plus and then plus.
Plus and then plus. Why is it plus and plus?
Opposite always positive.
Yep, this is the same as what I started off with, which was minus. And then the opposite and always positive. So far, so good? All right. So I'm going to get this denominator under here. It's very fortunate that I left this in factored form down here, because what do you notice? I can cancel the x minus 4s. And so my final answer here, once I have rationalized the numerator, would be x squared plus 4x plus 16 over x square root of x plus 8. You guys good on that? Okay. What else do you want to see or know how to do? It can be out of a homework, it can be off a review, anything. Pedro.
I was just going to ask, we don't factor out the x squared plus 4x plus 16?
X squared plus 4x plus 16 will not factor and have real roots. Good question.
We got to rationalize the numerator, right?
Yes. Yep. Yes, sir.
Can you go over like one of the first topics? It's like absolute value.
The absolute value stuff? Absolutely, yes. Okay, so I'm going to make one up here. We're going to rewrite absolute value of, I don't know, let's do 5x minus 2 without the absolute value symbols. And I'm going to look at two different cases here. If x is, let's say, greater than 3, and if x is less than 0. I'm just picking out numbers here, okay? So two different possible cases. Give me an example of a number that meets the first criteria, x is greater than 3. 4, okay. So we're going to test this first with 4. So if I put 4 into that absolute value, I have 5 times 4 minus 2. That would be 20 minus 2, which gives me what? 18. What is the absolute value of 18?
18.
18. Did the absolute value have any effect on what was inside it in this case? No. 18 inside the absolute value symbols, 18 outside, because absolute value takes whatever we have and it makes it positive. Which means if it's already positive, it has no effect on it whatsoever. So if x is greater than 3, what is inside the absolute value will be positive. Which means the absolute value has absolutely no effect on it whatsoever. So the way I would rewrite this then, without the absolute value symbol, would just be to recopy it. Over here, if x is less than 0, give me something that's less than 0. -1, sounds good. So test when x equals -1. So I have the absolute value of 5 times -1 minus 2. Well, 5 times -1 is -5. So what would I have inside the absolute value? -7. What is the absolute value of -7? 7. So what did the absolute value do here? The absolute value changed the sign. Over here, absolute value had no effect. If I didn't have the absolute value symbol around the -7, what's something else algebraically that you could do to change the sign? What could you do to it? Multiply, add, divide, subtract? Yeah, multiply or divide by -1, right? So if I take -7 and I times it by -1, it's the same exact result, correct? So if x is less than 0, then what is inside the absolute value will be negative. If what's inside the absolute value is negative, then I need to multiply what's inside by a negative so that it will become a positive, because that's what absolute value does to it, correct? I had the exact same answer as when I applied the absolute value when I multiplied what was inside by -1. So if I multiply what's inside by a -1, then I can write it without the absolute value sign. I now need to distribute that negative to fully simplify this. So I would have -5x plus 2. This is how I do it if what is inside is negative. If what's inside is positive, I just recopy it without the absolute value symbol at all. No change whatsoever. Do you guys have any questions for me about this? Please let me know if you have any questions at all. Yes, sir.
Is there a way we can see the answers to the review questions?
I don't have a key on me right now, but if you send me a message in Canvas, I will send you the answers. Yes. Yes, ma'am.
I just want to see a couple problems like number 6 where it's like the following expression should be written in the form.
Oh, like that right there. Yes. So when we have rational imaginary numbers. Yep. Okay, so let's do an example like that. So if I have, I'm just going to make something up here. 5, let's do minus 7i over 3 plus 2i. Something like that? Okay. So if I want to write this in the form of a plus bi, a single complex number, similar to when we're rationalizing either the numerator or the denominator, I want to multiply by the conjugate of the denominator. Yes, good clarification point. We will multiply by the conjugate of our denominator. So I'm going to multiply top and bottom by what? 3 minus 2i. All right. So in my numerator, I'm going to have to use double distribution. So I have 5 times 3, 5 times negative 2i. So I get 15 minus 10i. And then I need to distribute the negative 7i. So I have minus 21i, and then negative times a negative, I end up with plus 14i squared. Down in my denominator, because these are conjugates, it's going to do exactly what happened before, where that middle term, the piece that has just the I, is going to cancel out. So I'm going to square my first term, I'm going to square my second term, and it's subtraction in between. So I have 3 squared, which would give me what? 9. Subtraction in between always. And then I'm going to square 2i. 4i squared. Perfect. Up in my numerator, I can combine these two like terms. That would be negative 31i. What can I always replace I squared with? Negative 1. So I have 15 minus 31i, and then this is going to be minus 14, because I have 14 times negative 1. Down in the denominator, I have 9 plus 4. I'm going to combine these two like terms together and these two like terms together. 15 minus 14 would give us what? So I have 1 minus 31i over what? 13. Almost done. I want it in a plus bi form, so I need to make the first term a fraction, and I need to make the second term a fraction, since it's not going to reduce nicely. So I would have 1 over 13 minus 31 over 13i. Yep. What else do you guys want to see? Yes, sir.
Can we do like the I stuff, like I to the negative 33 or something?
Yeah, absolutely. Absolutely. I'll just kind of stay right here. So we have I. I is the same thing as the square root of negative 1, but this is the simplest form of that. I squared is always going to be equal to what?
Negative 1.
Negative 1. I to the third power, well, that's I squared times I, and I squared is negative 1. So I to the third power would be negative I. I to the fourth power, that's I squared times I squared. So negative 1 times negative 1, which would just give me what? 1. You want to do a higher power of I?
Yeah.
Okay, so let's do something like I to the power of 27. Is 27 divisible by 4?
No.
No. But if I take 27 and I divide it by 4, what would you get? Like, how many whole times does it go in?
6.
6 whole times. So I could rewrite this as I to the 24th, because that's divisible by 4, right? Times I to the 3rd power. If it's divisible by 4, like this one right here, it's going to simplify to be the same thing as I to the 4th power. So I would have 1 times I to the 3rd power, and what was I to the 3rd power again?
Negative I.
Negative I. So this whole thing simplifies to negative I.
How do you do the negative one?
How do you do the negative ones? So if I did I to the, let's do negative 11. Like that?
Yeah.
Okay. I to the negative 11. I want to rewrite this. First of all, I know that that makes it the reciprocal, right? I want the power in the denominator to be divisible by 4 so that that whole denominator simplifies to a 1. So how could I rewrite this idea so that I have I to a power that's divisible by 4,
I to the 8th times I to the 3rd.
I to the 8th times I to the 3rd, close. I like the way you're thinking. I don't have a problem with what you're doing there. I want to take this up a notch because I know that the numerator, whatever the power in the numerator is, I'm going to subtract this power and this power. So here, let me write it like this. X and Y that would be I to the power of X minus Y, right? So I want to get a negative 11 out of this. What could I do? I want this to be divisible by 4, and I want something up here. If I make that 1 bigger, instead of 11, if I write that as a 12, hold on. If I did I to the 12th power here, what minus 12 would give me negative 11?
The first power.
Yes. So if I did I to the 1st power up here, what's my denominator going to simplify to?
1 over I to the 1.
Not this guy.
Just 1.
The denominator is going to simplify to just be 1.
Wait, what?
I to the 12th power is 12 divisible by 4.
Yes.
Then it's going to simplify to 1.
Okay.
So I would have I to the 1st power over 1. So then fully simplified, this would be what?
I.
Just I. Do you want to try another negative one?
Sure.
Okay. Let me give us a clean space to look at it.
Did you get the 12 under there because you did I to the 1st minus I to the 12, which is I to the negative 11th, and you put it on the denominator?
Mm-hmm.
Okay.
That's exactly what I did. Give us a clean page. I'll put our powers of I up here. There we go. All right, so if I have I to the power of, let's pick something interesting. Let's do to the power of negative 29. So that would be 1 over I to the 29. I want to rewrite this as I to some power over I to some power. So I'm going to call those x and y so that I can try to figure this out. So I know that x minus y has to give me negative 29, right? And I want my y to be divisible by 4. Since I'm going to be subtracting and I want the result to be a negative 29, I don't want to use 28 because that's not going to, like, that would have to be 2 negatives, right? So what's something bigger than 29 that's divisible by 4? 32. Okay, so if I do x minus 32 equals negative 29, what would x need to be then? 3. 3 minus 32 equals negative 29. So here's the power in my numerator. And there's the power in my denominator. So if I do I to the 3rd power over I to the 32nd power, what's the denominator going to simplify to? 1. So I have I to the 3rd over 1. And how does I to the 3rd simplify?
Negative I.
Negative I is correct.
Oh, okay, I got you.
Make more sense?
Mm-hmm.
Okay. What else do you guys want to talk about? Yes, ma'am.
How do you complete the square again?
Completing the square. Let me think of something.
Is this the one where it's like b over b and then squared?
B over 2 and then squared. Yes. Yes, yes, yes. Okay, let's do 4x squared plus 20x plus 13 equals 0. If we want to solve this by completing the square, I just made up a quadratic. I'm going to go through this process differently than if I was graphing this parabola. When I'm solving something, I'm allowed to do things to both sides of the equation, right? If I'm trying to put this in vertex form, different process. Same big idea, but I can't do things to both sides because one of my sides would be like a y equals. When I'm solving by completing the square, I want this guy on the other side. I just want to be looking at my a and my b. So I'm going to subtract 13 from both sides. So I would have 4x squared plus 20x equals negative 13. I am not taking a GCF out, but I want my a value to be 1. So I'm going to divide everybody by 4. It will not move to the front. It is reducing my whole equation down. So I would have x squared plus 5x equals negative 13 over 4. We are going to add to both sides here. So x squared plus 5x plus something equals negative 13 over 4 plus something. This is where we take the b and we cut it in half, and then we square it. So b divided by 2 squared. So I'm going to do 5 divided by 2, and I'm going to square it. What would that give me? 25 over 4. That's what we're going to add to both sides. So on the left-hand side, I would have x plus 5 over 2 squared, because this is always going to be b over 2, is equal to, let's see, negative 13 over 4 plus 25 over 4. That's what, 12 over 4? Yeah, 12 over 4, so 3. And then I want to take the square root of both sides. When you take the square root of both sides, how many answers do you get? 2. So I have x plus 5 over 2 is equal to plus or minus the square root of 3. Last thing I need to do is get rid of this 5 over 2, so I'm going to subtract it from both sides. Cancels out here. And I have x equals negative 5 over 2 plus or minus the square root of 3. And I've got my 2 solutions, my 2 roots. Yes, ma'am?
Can you do one where it's like the dx thing, where it's like something squared, something x squared plus dx plus, you know?
Oh, yeah. Were you trying to figure out what that term would need to be? Absolutely. Yes, sir.
You lost me like at the arrow.
When I went with the arrow there?
Yeah, so like the x squared plus 5x plus 25 over 4.
Mhm.
You just discard the 5x, or?
Nope. Let me show you what happened there. If I take x plus 5 over 2 and I square it, I would
How do
need to
you-
use double distribution, right?
How do we get 5 over 2?
B cut in half. Our b value was 5x.
Yeah.
We took the 5, we divided it by 2.
Oh, okay.
That's where I got the 5 over 2 from. If I use double distribution here, I get x squared plus 5 over 2x. And then I distribute here, so then I have another plus 5 over 2x plus 5 over 2 times 5 over 2. That's 25 over 4, right? What happens when I add these two like terms together?
Just turns into 5.
Turns into 5x. Because remember, when we square a binomial, we square the first term, we square the last term, we multiply the two middle ones together, and times it by
2.
2. X squared, 25 over 4, multiply them together, and times it by 2.
Wait, I'm sorry.
Uh-huh.
I just don't understand like why we put the x in there too. Because is that part of the b?
Why the x is in there?
Yeah. Because why do we do the b over 2 squared? Why are we putting the x in there too? For like the b over 2.
This right here is equivalent to this. These are the same. They're written in two different forms, but this is exactly the same as that.
Oh, okay.
So I have to have the x there, or else I couldn't get my x squared and I couldn't get my 5x.
Okay.
Yeah.
I got you.
Okay. Does that make more sense now? Okay, cool. Carrington, you had a question about when we're going after that missing value there. And you want to know specifically the middle one, right?
Yeah, isn't that what he says? Yeah.
Yep. So if we had like x squared plus dx plus something like this. So to figure out the things that d could be, to make a perfect square trinomial, I need whatever this is. I'm going to cut it in half, and I'm going to square it to get this. So to take that and translate it over here, D cut in half squared would have to give me 49, correct? So how do I undo this process then? Square root of both sides, which immediately means what about my one side? What does that mean about the right-hand side? Plus or minus? Yes, ma'am.
I thought you didn't have to put plus or minus when the square root was already part of the problem.
Correct. But this was my problem.
Oh.
This is my process, so I have to do the plus minus there. Good question. What would I still need to do here to figure out what the D value is going to be? Multiply by 2 on both sides. So that D value could be a positive or a negative 14. Awesome. If you guys have any questions tonight, please send me messages in Canvas. If you were not able to get your video uploaded, please contact me. I can try to troubleshoot some different things. Worst case scenario, I will send you my number, text it to me, and then I can get it posted that way. All right?
Can you go back to the last